I am Deepak Loomba. Through this video, I desire to showcase a discovery I made in the area of planetary science. The said discovery leads to a major difference in the calculation of the system energy of both Earth and Sun. And it also leads to a very major change in how we calculate and understand the precession of Earth. The precession itself will be explained further. To begin with, it is important to inform that the motion of Earth as we observe it is a result of various motions, all superimposed on each other. There is rotation and revolution around the barycenter, there is precession, there is change in the orbital plane, there are changes in the ellipticity of the orbit, there is a change in the orbital plane itself, and there will be a few more other aspects of motion of Earth as we keep on enhancing the frame of our reference. All of these motions, revolution around Sun and rotation around the axis, are the most prominent along with the rotation of Moon around Earth. And there is another one which is very important and critical, that's precession of Earth, because that leads to change of seasons across a very large time as we would find it ahead. The area of my investigation is revolution, tilt of Earth's axis and precession, all three of them, and the interconnect between all three of them. We are in no dispute vis-a-vis rotation of Earth or other diminutive parts of the motion of Earth. We start with the current understanding of revolution, which is the time within which Earth completes one full revolution of Sun, which is approximately 365.25 days, through which Earth travels close to 940 million kilometers. Today, the Earth's axis is tilted at approximately 23.44 degrees to the plane of the orbit of Earth around Sun. This still keeps on changing. There is a cycle, and during this cycle, which averages close to 40,000 years, the tilt of the axis varies between 22.1 degrees and 24.5 degrees. demonstrate my theory, I have made some approximations, but those approximations really do not impact the fundamental theory that I am advancing. It all started with a doubt about an observation that's, well, a known fact. We know from observation that Earth maintains a constancy in the orientation of its axis throughout the revolution, barring a slight change that happens because of precession. Well, for our purposes, we ignore precession as of now. So would I assume this to be Earth and these two as the axis that passes through the Earth around which it is rotating? The Earth maintains this tilt to the orbital plane, that's the plane which is formed by connecting all points of the circle in which the Earth revolves around Sun. So would this be Sun? Then Earth is revolving like this, maintaining the incline of its axis throughout the 365-day period till it reaches the point where it started from. There is no change, barring a slight change that happens because of precession. Well, let's ignore it for the time being. It really is not going to impact the overall theory. So, once again, the Earth maintains its tilt. This tilt is maintained throughout the cycle of revolution of Earth around Sun. The axis keeps on pointing towards a far star all throughout the entire revolution. So the doubt that I harbor is, why does Earth maintain its axis tilt and the orientation throughout the entire period of revolution of Earth around Sun constantly, pointing towards the same North Star? I really could not understand why should it do this. And believe me, after a few months of thought, I recognized some startling facts that were left unheeded by science, which I have compiled and I'm presenting you herein as my discovery. We have kind of a mock-up of the Earth. This is my Sun and this is the orbital plane. And we start with, over here, this is when it is, the date is 1st of January, 00 hours and 00 minutes. Earth actually points something like this, whereby the North Pole is farthest from the center of Sun. This is my Sun. And as it progresses through the year, the North Pole keeps on getting closer and closer, as you see, to the Sun, till we reach this point when it is the closest. In the next half year, it again starts going farther and farther till we reach the 1st of January of the next year, when it points farthest from the Sun. The question: if one would really create a graph of the position of North Pole from the Sun, you would find that the North Pole is actually oscillating. It goes farthest from the Sun, then reduces down to the minimum, and then again goes farther in the next year. So let's for a moment assume that we've got a celestial motor which could be used to switch off any specific part of the motion. Now let's for a moment just assume that we have switched the revolution motor off. The moment this revolution motor would be switched off, remember, the Earth is still undergoing imaginary revolution, while it is of course not really undergoing a revolution, and you would find that the North Pole is actually undergoing this kind of motion in the first 6 months, and then it again comes back to this very position in the next 6 months. What could be the reason of Earth undergoing this kind of an oscillation? I mean, there could be two options of this oscillation. It could be, of course, as I am demonstrating, a to and fro component of Earth's motion. But then the question is, when it came down to this point, what stopped it from tumbling down? Remember, it's a Newtonian framework, and there is nothing no external force that would have stopped Earth from tumbling down further. But it is not tumbling. So then the only other possibility is that there is some kind of an angular motion which is happening, which actually leads to this oscillation of North Pole from the center of Sun. For an ideal case, I want to assume a universe that has nothing other than Earth and Sun, such that the Earth is not spinning. So let's just assume that though there exists an imaginary line, which we called the axis of Earth, but it really is not an axis because there is no spinning that is happening around this imaginary line. So, but we still consider this line. And now since there is no rotation happening, apparently there would be no precession happening. So how would Earth in such a case be revolving around the Sun? By laws of physics, the position of each point of Earth vis-a-vis the center of revolution will be constant to ensure conservation of angular momentum in Newtonian conditions, with absence of any external torque. In other words, the north hemisphere would be tilted away from the Sun throughout the year. So would we start our year from here, and let's assume that the Earth is not spinning and hence it is not pressing, then in such a case, Earth would have been revolving around the Sun, static, not spinning, in this manner, such that the North Pole would always point farther from the center of the Sun throughout the year, and hence there would be no movement of this axis, or rather the orientation of this axis will not change vis-a-vis the orientation of the axis of Sun, which is this. So it would maintain the same orientation, and this should not surprise anybody who studied physics or science in school, because even with a very simple example, would we clutch an irregular shaped single material solid within 2 mounts of a gyro and revolve it with a thread such that the solid is free to position itself in 4 pi steradians, then the position of any point of the solid in such a system remains unchanged vis-a-vis the center of revolution. Or say, would I insert an irregular object like a stone in an empty bottle and then revolve the bottle, tying it with a thread such that the stone is free to move inside the hollow space of a bottle, the object will maintain its distance from the center of revolution throughout the entire circular path if no external force is acting on the system. This is a slightly upgraded mock-up that I'm going to now finally demonstrate what I have discovered. Here I have got Earth with its axis which is tilted. This pointer which is colored shows the South Pole, and this long strip of paper shows the North Pole. Here we are more or less oriented at 00 hours of 1st of January of any specific year. Now, this arrow demonstrates how would the orientation of the axis of Earth vis-a-vis the Sun would behave. Would it be constantly facing away from the Sun? Now, as you see, as we go around the year, and we do know that Earth revolves around the Sun in a counterclockwise mechanism. Please remember, we have assumed that Earth is not spinning, which means that there is no precession that is happening. So this is how the Earth would actually be revolving around the Sun throughout the year, such that the North Pole, and this is the projection of the North Pole, while this is the projection of the South Pole, the white strip constantly points away from the center of the Sun. So this is how Earth, which would not be spinning, would actually be revolving around the Sun. And here we are back to where we started from. Now we do know that we assumed we've got a celestial motor which could actually start spinning the Earth. We know that it is the spin of Earth which causes precession. And we've also been told from observation that Earth has a precession cycle of 25,771.5 years. That's the time within which the precession of Earth, which actually means, as I had told earlier, that this axis sweeps a cone through a full cycle of approximately 26,000 years. So now let's assume that we've started the celestial motor on, which starts spinning Earth around this axis. The moment we've started spinning it around the axis, we've got precession starting to happening, and we have been told that precession is 26,000 years, which would then mean that Earth would actually continue to rotate and revolve in such a manner that the change in the orientation of Earth, of the Earth's axis, is going to happen only by a very slight amount through 1 year. So by the time Earth would have come back to its original position, precession would, the understanding of precession would enable to move the Earth slightly towards the right, just slightly towards the right in 1 year. The next year, of course, this is not happening like a quantum jump as I'm showing, it is happening gradually throughout the year, but for ease I'm showing it at the fag end of the year. Now it would actually go around for another 1 year, come back to the original position, and the Earth would now be pointing still a little more, and then still a little more, and still a little more, and still a little more, and in 26,000 years it would have then completed this whole cycle. But the interesting fact, there is no reason for Earth's axis to not maintain its constancy would we ignore the slight precession vis-a-vis the axis of Sun through the year, even after the spin that the celestial motor enables has been switched on. Earth should have been revolving like this, only showing a very, very slight change in its orientation at the end of every year. We decide to make a quantum leap, a different understanding of how the Earth actually revolves around the Sun and what is precession and how much is precession. Let's for a moment assume, and we are still assuming, that the Earth is pressing with a speed much higher, or the rate much higher than the one that has been observed or that has been actually informed by science. Let's take that the Earth is pressing at a rate of approximately 1 year. What would then happen? Earth would actually be changing its orientation vis-a-vis the center of Earth with every moment, and would hence maintain the orientation of its axis through the year. Now, how the precession is happening is beautifully demonstrated by how this arrow and this indicator are moving vis-a-vis each other. Please pay attention. Look at how this arrow, which actually showcases the precession, this arrow, which indicates the North Pole, is coming closer and closer to this arrow. After 6 months, it is actually facing the arrow, and after another 6 months, by the time we come to the original position, it is again facing further away from this arrow. Now, which means that would we press Earth with one ear, we would actually get the orientation of Earth the way we observe it currently. So, this is my first and probably half of the major discovery that I did, that the moment you start pressing Earth, and that is what I am demonstrating right now. The moment you've pressed Earth faster, which is almost about a year, you would actually have the orientation of this axis maintained constant vis-a-vis the far star, which coincides with our observation. Now for a moment, let's assume that the cycle of precession, which is the rotation of this indicator vis-a-vis this arrow, is slightly faster than the revolution of Earth, which would mean what? Here we go. As you see, we are pressing, but by the time we arrive to the initial position where from we started, we have understood that the precession of Earth, which is the precession cycle of Earth, which is denoted by the concurrence of this arrow with this indicator on the same side, actually happens slightly before. As you see this indicator, it happens slightly before the year has completed. Now, by the time the position of Earth would be 00 hours of 1st January again, because of this faster precession cycle, the Earth would actually point slightly, kind of tilting clockwise by about 20.41 minutes. Let's again take another cycle for another 1 year. As you see, Earth is pressing vis-a-vis this arrow, and by the time the year is done, the revolution of Earth is completed, Earth would actually then, because this cycle is faster, would be pointing again slightly farther ahead. Go in for one more time to fully understand the process. As I said, this is the orientation of the Earth's, the Sun's axis vis-a-vis the axis of the Earth, and this indicator actually showcases where the North Pole is pointed. Now we started the 3rd year and we are still going, and as you see, Earth is pressing around its own axis with a speed almost close to 1 year, faster by 20 minutes and 41 seconds. In the 3rd year, the Earth, by the time it would reach its original position, it would have gone further ahead by 20 minutes and 41 seconds. Now, 20.41 minutes. So, as you see, with every passing year, this position of Earth would keep on changing little by little by little by little by little by 20.41 minutes every year, and at the end of close to 26,000 years, Earth's axis would have taken a full circle around the imaginary line and would have come back after 25,771 years to the same point where it started. So, what we observe currently as precession is actually not precession. It's the disparity, it's the gap between precession and revolution of Earth, which is 1 year. Earth's precession is faster by 20.41 minutes than the revolution of Earth. What we today mention through my model, through my markup, I am proving is that the precession of Earth is actually 20.41 minutes less than the revolution of Earth. So the precession actually is almost close to 1 year, and it is not 26,000 years as has been told in the literature. So these two are my major discoveries. A, once again, that the precession is 1 year. It is not 26,000 years. It is 1 year less 20.41 minutes. 20.41 minutes actually, or rather what we call today precession is of 20.41 minutes every year, is actually the gap between the year and the precession cycle. So these are my two discoveries. Now this discovery has a very major impact on understanding of the system energy, the energy of Sun and Earth as a system, because you've got a much faster precession, and hence there is going to be a lowering of the system's energy, because as we know that precession happens in a clockwise direction. Would I look from the north of the sun, while revolution happens in an anti-clockwise, and so does spinning of Earth. So this is my presentation. These are my two major discoveries. If you want to connect with me, you are most welcome to write me on D-Precession at deepakloomba.in. You are welcome to write to me on my blog, which is Chingari, CHINGARY.blogspot.com. Twitter to me on @DEEPAKLOOMBA_, which means @Deepak Loomba_. Thanks a lot.